Hello everyone, I am Dr. Lalitha, Assistant Professor, Department of EEE, MLR Institute of Technology. In today's video lecture, I am going to explain about the types of elements and Ohm's law. Coming to the types of elements, so main network elements are classified into four types. They are active and passive elements, unilateral and bilateral elements, linear and nonlinear elements, lumped and distributed elements. So mainly all the network elements are mainly classified into these four types only. So now let us see each type in detail. So the first one was active and passive elements. So what are active elements and what are passive elements? So active element is a type of element which have the capability of delivering the power. Means it can deliver power to any other external elements or sources. So these types of elements are called as active elements. So examples of these active elements are voltage sources and current sources. So these two types of sources are examples of active elements. Next, coming to the passive elements, the elements which have the capability of receiving the power are called as passive elements. So examples of these passive elements are inductors and capacitors. So these inductors, capacitors, resistors, all these are passive elements. They are having the capability of receiving the power. So next, coming to the second types of elements, unilateral and bilateral elements. So what are unilateral and what are bilateral elements? So these unilateral and bilateral elements are mainly classified based upon the VI relationship, means voltage current relationship. So unilateral element is one which have different for two different values of current or two different directions of current. So this relationship will be different for two possible directions of current. So examples of these unilateral elements are vacuum diodes, silicon diodes, etc. So coming to the bilateral elements. So these bilateral elements in these type of elements, the voltage current relationship will be same for both possible direction of currents. So VI value or VI relationship is same. So examples of these type of elements are high conductivity elements. So all high conductivity elements comes under the bilateral elements. So next, coming to the third type of elements, linear and nonlinear elements. What are linear elements? So these linear and nonlinear elements also is classified based upon the VI characteristics. So in the linear elements, the VI characteristics, if we draw the VI characteristics means voltage current. If we draw the graph for these type of elements, that line will be straight line passing through origin. So such type of elements, for these type of elements are called as linear elements. Means the voltage current characteristics, the straight line passing through origin should be obtained. So these type of elements are called linear elements. Next, coming to the non-linear elements. So opposite to the linear elements are non-linear elements. That means if we draw the graph between the voltage and the current, the line will not be straight line passing through origin. So these type of elements are called as non-linear elements. So examples of linear elements are resistors and examples of non-linear elements are inductors and capacitors. Next, coming to the fourth type of elements, lumped and distributed elements. So what are lumped elements? So these lumped elements are very small in size and simultaneous actions will be taken place at any cause at same instance of time. So simultaneous actions can take place at same instance of time. So such elements are called as lumped elements. So examples of these lumped elements are resistors, capacitors, etc. Coming to the distributed elements. So in order to know about the distributed elements, for example, if we consider a transmission line. So that transmission line will be so much long and there will be elements like resistors, inductance and capacitance throughout its length. But we can't electrically separate those terms. So these type of elements are called as distributed elements. That means we know that the values will be present, but they are not electrically separable for analytical purposes. They are not electrically separable. So these type of elements are called as distributed type of elements. Now coming to the most important law in our electrical terminology, Ohm's law. So what is an Ohm's law? At constant temperature, the current which is flowing through a conductor. Suppose for example, I had taken one conductor. Okay. So the current flowing through this conductor, let us consider the current I is flowing through this conductor. At constant temperature, the current flowing through the conductor is directly proportional to voltage applied across it. Means I is proportional to V. Means how much amount of voltage I had applied. How much amount of voltage I had applied, that value will be proportional to the flow of current in the circuit. So, the amount of current which is flowing through the conductor is directly proportional to the applied voltage across it, provided that all the physical conditions and temperature remains constant. This is Ohm's law. So, we can determine the formula for the Ohm's law as V is equals to I into R, where V is the voltage across the conductor, I is the current flowing through the conductor, and R is the resistance provided by the conductor to the flow of current. Now let us see the relationship between voltage, current and resistance. So now we can determine the value of one parameter if remaining other two parameters are known. Suppose for example, I want to find out the value of current. Okay, current value I want to find out. So I am having the values of voltage and resistance. I am having the values of voltage and resistance. So by using the Ohm's law, we can determine the value of current. So how we can determine? As we know that V is equals to I into R. So we have the value of voltage. What is the value of voltage? In the first one, I am considering the first case. The value of voltage is 3 volts. Okay. So I want to find out the value of current. So V is equals to IR, I is equals to V by R. I is equals to V by R. So what is the value of V here? 3 divided by what is the value of resistance here? 6. So 1 by 2, that is equals to 0.5 amperes. Similarly in this case, so I is equals to V by R. So V divided by R, 6 by 6, 1 amperes. Here in the 9 volts case, so I am taking the voltage as 9 and resistance as 6. So the value will be 1.5 amperes. So likewise we can determine the value of current in the circuit. If for example, I have the value of current and I have the value of resistance. So now I want to find out the value of voltage. Can I find out? Yes, easily I can find out. So now let us see. Let us consider this first case. Okay. So here I am having the value of current. So I is equals to 0.5 amps. I am having the value of current. I am having the value of resistance. R is equals to 6 ohms. Now I want to find out the value of voltage. So what is the formula? V is equals to I into R. What is the value of current? I is equal to 0.5. And what is the value of resistance? 6. So the value is 3 volts. So likewise we can determine the unknown value of any parameter if remaining two parameters are known. So now let us see some basic problems on the Ohm's law. Now see the first problem. So if the resistance of the electrical iron is 50 ohms, means they had given the resistance value as 50 ohms, and a current of 3.2 amperes, means the current value is 3.2 amperes. To find out the voltage between the 2 points. So according to Ohm's law, we know that V is equals to I into R. So I means 3.2 into R means 50. So voltage value is 160 volts. So now let us see the second problem. An EMF source of 8 volts, EMF is nothing but a voltage. So we can take voltage as 8 volts. Is connected to a purely resistive electrical appliance. An electric current of 2 amperes, means current I is equals to 2 amperes flows through it. So consider the conducting wires to be resistance free and calculate the resistance offered by the electrical appliance. What is the resistance value? So according to Ohm's law, we know that V is equals to I into R. So from this we can determine the R value. What is the value of R? R is equals to V by I. What is the value of voltage? 8 volts divided by what is the value of current? 2. So the value of resistance is 4 ohms. So likewise, we can determine the unknown value of any term if the remaining other two terms are known. So now we'll determine the value of the power by using this Ohm's law parameters. So we know that what is a power? What is power? Product of voltage and current is called power. So we know that P is equals to V into I. So if they had given us the values of voltage and current, we can determine the value of power by using this formula. But if they had given us the terms in terms of current or voltage or resistance, we can't determine the value of power with this. So from this formula, we are going to derive two more formulas for the easy solvation of problems. So that also based upon the Ohm's law only. Now let us see the value of power when the value of voltage and resistance is given. So according to the Ohm's law, we know that V is equals to I into R. V is equals to I into R. Now substitute the value of current value. So I is equals to V by R. So substitute the current value in this formula. So P is equals to V into V by R. So what we got? V square by R. So P is equals to V square by R. Means when the value of voltage and resistance are given, we can use this formula in order to determine the value of power. Similarly, P is equals to I square R. This equation also we can derive from this basic equation P is equals to V into I. So we know that P is equals to V into I. So according to the Ohm's law, we know that P is equals to I into R. So I into R into I. So we will get I square R. So P is equals to I square R. So if the value of the current and resistances are given, we can use this power formula in order to determine the value of power. Similarly, if the value of voltage and resistances are given, we can use this formula in order to determine the power. Or directly, if they had given us the value of voltage and current, we can determine the value of power by using this formula. Now let us see the applications and limitations of Ohm's law. Coming to the applications of Ohm's law. So in order to determine the value of voltage or resistance or current in any electrical circuit, we can use this Ohm's law as we had seen in the above problems. So the main application of this Ohm's law is in order to find out the desired voltage drop across any electronic components, we can use this Ohm's law. And next one was, it can be used as a shunt. Shunt means in order to divert the value of the current. In order to divert the current, we'll use the DC shunts. So in these DC shunts as well as in the DC ammeters, we can use this Ohm's law. These are the various applications of Ohm's law. Coming to the limitations of Ohm's law, as I had told you in this statement, it works only under the constant temperature. At constant temperature only the Ohm's law will be considered. So Ohm's law is not applicable for unilateral elements. Unilateral elements like diodes, transistors, means in unilateral elements what will happen? The current will flow only in one direction. So in such cases, Ohm's law will not be useful. For nonlinear electrical elements like resistors, capacitances, etc., so the ratio of the voltage and current won't be constant. So in such cases also Ohm's law is not applicable. So these are the main limitations of the Ohm's law. Thank you.